Okay, well, thanks everybody for waking up so early. I really appreciate that. I'm actually up late. I live in Brisbane in Australia, and just yesterday, I think, whatever counts as yesterday, I was in San Francisco at the launch event for a product that my company is building, got straight on a plane here, had a couple of beers, fell asleep, woke up at 2 a.m., couldn't get back to sleep, and so after a very long bike ride through the city of London throughout the night, which was beautiful, here I am giving you this presentation late in the evening on my body clock. So I hope you enjoy it. It's all about software-defined networking. And I'll give you an outline here of all of the things that we'll go through. But we'll start with just an introduction of myself, because a lot of you probably don't know me. I've never spoken at any conference in the UK or Europe before, and my work is a little bit obscure, not to sound too hipster about it, but you may not have heard of it. So there's a photo in case you weren't sick of seeing my face in the flesh. I'm a security guy in general. I'm actually a recovering climatologist. So for many years, I worked for the Australian Bureau of Meteorology on long-term streamflow forecasting. And if you ever fly a plane or are in a plane anywhere in the southern hemisphere, all of the weather data that's collated and sent to the pilot is actually done by a piece of software that I wrote myself. It's pure Oracle PL SQL, 100%. It's a disaster. Anyway, after that, after I got out of that, I worked for Red Hat for 5 years, and I was the manager of part of their security team that looked after all of the products written in Java, as well as OpenStack. I'm now the manager of product security for Console, which is a Silicon Valley-based startup with an engineering base in Brisbane. And I'm also the founder of the Open Daylight and Onus security teams. And we'll talk about Open Daylight and Onus at some length. They are probably the two most prominent SDN controllers on the market today. So open source SDN, or SDN in general, I think is a really interesting topic because it's hot. If you look in the media, everybody's referencing SDN. There's a lot of development being driven, and no one seems to actually be focusing on the security of this stuff. And that will become more evident as we go throughout the talk. A lot of people, the analysts, are calling 2015 the year when this finally goes into production across the board, and we can see that happening. Actually, Google's had SDN in production for years, but they won't talk about it. It's really interesting. If you ever go to any presentation by a Google employee about SDN, they will speak about SDN. They will not say a single word about Google's internal SDN. It's definitely off limits. There are other companies, though, that are publicly using it and saying what they're doing. PACnet is a good example. They're a layer 2 wide area networking company based out of Hong Kong, I think, that are owned by Telstra, Australia's biggest telco. So the question is it secure? I think you know the answer. But before we ask that, we should say, what exactly is SDN, or software-defined networking? Actually, I was on a call a couple of weeks ago with a steering committee for the FCC, the US Federal Communication Committee? Any Americans? Anyway, the FCC, where they were talking about SDN security. And they asked me for some input and advice, and I said, well, first of all, what do you mean by SDN? And we wasted 40 minutes of this 1-hour call with all the people trying to decide what the scope was and what SDN actually meant. So in the background, we have the Wikipedia HiveMind definition of SDN, and I think that kind of speaks to the key point. Traditionally, you have layer 2 or layer 3 networking devices, so switches or routers, that have a converged control plane and a data plane. So think about a typical Cisco router or switch. It's one device, it's one software stack. You can SSH in or telnet in and run commands that control the way that packets are routed or switched. So that's the control plane. And then that same software stack actually performs the routing or switching, i.e. the data plane. And so software-defined networking is really about, in my mind, at the simplest level, decoupling those two things. Decoupling the control plane and the data plane, and allowing you to have a pure software control plane, and then the data plane more coupled to the hardware. So I mentioned I used to work for Red Hat, and you may not be able to read the text in the little boxes at the top, but I'll go through it. And this is what Red Hat did, amongst others. SUSE also helped, and Canonical. They took proprietary Unix OS, tightly coupled to a CPU architecture and hardware, and killed it by having x86 commodity hardware with an operating system like Linux or BSD that was decoupled from that hardware. And you may argue that some of these are not completely dead yet, or the Oracle Solaris zombie is kind of lurching along, but they're rapidly dying. So here is my very contentious point, is that SDN could do this. If you take the proprietary control plane tightly coupled to a proprietary data plane and switching hardware or routing hardware, and then separate it out. So you have an open source software-defined control plane, and then you have either white box switches or white box or even virtual routers. Then you could do this. Now, there's a bit of proof for that. These are all different media snippets, either from the trusted media or the company in question's own website. So Brocade has publicly said they want to be the Red Hat of open daylight. Huawei is all in behind Onus. Actually, it seems to be all Chinese companies backing Onus, except Cisco, who backs both Onus and open daylight. And then Juniper, who got into open daylight and then backed out of it. I'm not quite sure why. But here you have the bottom right one is actually Cisco's open SDN controller. It's just a productized version of open daylight. So it's very interesting. They're definitely paying attention to this stuff. But are they paying attention to the security of it? So let's take a look at the attack surface. As I said, on a traditional network, most of the networks that we have today, you have the data plane and the control plane converged together on a single device. Software-defined networking allows you to factor the control plane out to a separate controller, and this has some advantages from a security perspective. One of the key advantages, I think, is that it allows you to put the controller in an isolated network segment. You can theoretically do that with converged devices. You know, you can have the management interface only available on a management network, and you can have the data plane only available on the data network. But a lot of them out of the box, the management network is available to anybody on any of the ports in the switch or anybody who can access the router. Whereas with a software-defined SDN controller, it's a separate system. You know, it's a VM or a server or something, so it's very easy to physically isolate it in the network. The disadvantage is that now you've got an extremely high-value target, because in a traditional environment, you'd have to go around and enumerate all the switches and routers and take control of them one by one. In an SDN environment, if you control the controller, you control the entire network. So it's a very high-value target. So that attack surface, you think, is fairly straightforward, right? In a traditional converged device, you can attack it via both the control plane and the data plane. Once you separate them out, you can only attack the control plane via the control plane, and you can only attack the data plane via the data plane. It's not actually the case. Does anyone have any guesses? Welcome to yell out if anyone has a theory as to how that may not be the case. Yes? Sorry? The data plane could influence the control plane. Yes, it can. So SDN controllers are also exposed via the data plane, and a good example of this is when an OpenFlow switch, so OpenFlow is a protocol that's commonly used for SDN controllers to control switches, to tell them how to forward packets. It gives you flow rules, and you get an incoming packet and check against all the rules in the table and then switch it accordingly. If it doesn't match any rule that's been provided by the controller, it forwards a copy of that packet verbatim to the SDN controller and says, I don't know what to do with this. Please tell me how to switch it. So if there is some vulnerability in that processing logic on the SDN controller, then you can traverse from the data plane to the control plane. And we'll see an example of that in a minute. So you might notice here that I'm really focusing on the control plane. I'm not focusing on the white box switches or virtual routers that are at the other end of this, because the scope would be too broad. The only person I'm aware of who's actually done that is Gregory Pickett. He's got a Black Hat 2015 talk that's pretty decent if you want to check that out. So here's a depiction of how the attack surface actually exists in SDN. As you can see on the right, it is possible for an attacker to traverse from the data plane to the control plane, and we'll see a live demo of that a little later in the talk. So recent SDN vulnerabilities. There's a whole bunch of competing SDN controller implementations, and a lot of them have come out of research. There's been Floodlight was probably the original one that came out. There's been a whole bunch of research ones that have been written in Python, and then it depends how you define SDN. If it's just layer 2, then there's not so many. If you include layer 3, then there's a whole bunch of other stuff that's come out to try and automate routing as well as switching. A lot of it's written in Python, a lot of the research projects, and pretty much none of it is used in production yet, except for the two big players, in my view, Open Daylight and Onus, where there actually are production deployments that you can point to today. Now, really interestingly, they're both written in Java, they both use OSGI, and they both run on top of Apache Carafe. Is this because that's actually just the ideal architecture for building an SDN controller? I'm not convinced. I mean, I was the security response guy for the JDK, for Apache Carafe, for a whole bunch of applications written in OSGI for many years, and the whole stack is completely fucked. So I don't know why they both chose it. I think it may be a case more of Open Daylight went with that stack first, and then Onus said, well, let's follow to make it compatible for developers. The other thing that's interesting is who's backing this stuff. So Open Daylight, or ODL as we'll refer to it, everybody else refers to it, is a project of the Linux Foundation. I'm not sure if everybody's familiar with the Linux Foundation, but they're a non-profit organization, and all of the big commercial players involved in Linux development give them money, and they operate as a kind of central governance point, a non-partisan governance point for open source development. And so they run the Open Daylight project, and all of the corporate contributors are members of the Open Daylight Foundation. They give them money. Company I work for is a silver member, so we give them a little bit of money. Companies like Cisco give them tons of money and full-time developers. Onus is a little bit less structured in its governance. It actually came out of a university project, but it's really interesting who's backing it. China Unicom, China Telecom, and Huawei. So all these big Chinese players are backing it, and so Cisco, who also backs Open Daylight. So something weird going on there. Okay, so enough of that. Let's look at some vulnerabilities. This is how I got started in SDN security. Back in December 2014, I started working with this new company. We're doing all this work with software-defined networking, and I was brought on as the head of security for the company. So my boss said, take a look at this Open Daylight and Onus stuff, see what you think from a security perspective. So I started looking around, and there was no security reporting mechanism. There was no security response function. There were no security advisories. And I thought, well, this isn't good. There must be security vulnerabilities. Spent about 10 minutes pen testing the code, and I was searching around. I thought there might be an XXE vulnerability in some of the interfaces. Was Googling around. Turns out it was already reported. And it was dropped on the full disclosure list, I think in August 2014, and just dumped there. Nobody from the Open Daylight project had picked it up. And so I said, OK, this is an issue, and use this to instigate the formation of the Open Daylight security team. Just show of hands so that I don't waste everybody's time if it's not necessary. Who is familiar with XXE vulnerabilities in the room? About half of you? OK, so I'll go into a very small amount of detail. Basically, when you have a server-side process that's consuming an XML document provided by a client, that XML document can include a doc type declaration, which is kind of like a definition of some constants. And those constants or entities, external entities, can actually refer to, rather than just a string literal, they can refer to the contents of a file or URL. So you can effectively, in the header of the XML, declare a constant whose value should be resolved to the contents of a file. Then later on in the document, expand that reference. The file will be read, and its contents will be inserted into the document. If you can then get that result pushed back to you, you can read any arbitrary file on the server. And so I'll demo that in a second. Now, it's probably hard to see at the back, but that's the patch commit. And this is a little pet bugbear of mine. If you're ever auditing Java applications, first thing, look for XXE. Every Java application is vulnerable to XXE until they fix it, because none of the parsers disable external entities by default. In 2003, Microsoft disabled external entities in the .NET XML libraries by default, and they've been like that ever since. I'm not a huge Microsoft fanboy, but I'm saying even they did it right in 2003. Now, the problem is that there are, I think, JSRs, Java standard specifications, that require external entities to be enabled. So when I go to the developers of the XML libraries and say you should disable this by default, they say we can't because it would break compatibility with standards. So therefore, all of these Java libraries don't disable them by default, and you have to set feature and set these values and disable them. So that's the patch commit. All right, let's go to a live demo. So it's not actually a live demo, because I've done that too many times, and I know better. It's a video. So I'm running Open Daylight. I'm just running the Carafe console here, which is the application container, the OSGI container that runs Open Daylight. And I'm going to install the netconf SSH feature. I'll talk about what netconf is in more detail in a minute. This allows me to then SSH in on a port and interface with netconf, which is an XML-based vocabulary for configuration of Open Daylight. Now, I have to give the admin password. It's admin by default, and they won't change it. So then I provide an exploit, which I'll come back to in a minute, that gets the contents of etc passwd, and there you see it in the response. So I'll come back to the exploit part of this. Oops. Sorry, it's a little bit fiddly. Okay. So netconf is a standard mechanism for configuration of networking devices that's based on an XML vocabulary. And it's transport neutral. So you can do it via REST, that's how a lot of people do it, but you can also just do it via raw SSH as a transport mechanism, which is what we do here. I'm providing the default admin credentials, admin, which ship with every version of Open Daylight, because there's actually dependencies in the code on it, and they won't let me get rid of the default, but you can use an unprivileged user as well, so it is a legitimate flaw. So I'll pause it here. So what happens is the netconf server gives us a little XML document, which is a handshake, essentially, saying here are the things that I'm capable of. Here are the objects and parameters that you can manipulate. And then I provide it with a response that includes a declaration of an entity called XXE that resolves to the file etc passwd. Then I give it a very simple configuration command, which resolves the entity XXE. Thank you, sound man, video man, for that. And in the response, then we actually get the contents of that external entity. If you can zoom out, that would be great. Okay. So let's resume presentation. Oops. Okay, so that was the netconf issue. And in resolving that issue, we formed the Open Daylight security team. There was a whole bunch of media drama about it. You can look it up. Just look up the CVE ID or Open Daylight security. And the media had a big spaz because all of these big vendors who were behind the project obviously just didn't pay any attention to security. Gregory Pickett found this vulnerability, dropped it on full disclosure. Nobody picked it up. And then some random guy from Australia had to come and clean up the mess. So now we have, at this point in time, this kind of chronological journey here, we now have a security response process in place for Open Daylight. And a bunch of research came out that affected pretty much every SDN controller. And this was a topology spoofing flaw. So what happens? You're talking about these layer 2 SDN switches, and they're not actually using the same protocols as a typical switch. So what happens when you've got a server or a host, and it's plugged into a port on the switch, and then you physically disconnect it from that port and plug it into a different port? The rules inside that switch now need to know that when I'm sending traffic to that host, that MAC address essentially, that I route it through a different physical port. And so this have this host migration thing, where they can say, when a device connects, there'll be a packet in message, and it can say, hi, I'm this MAC address, and then it will start pushing traffic to that MAC address. So the issue is that any attacker can just impersonate somebody so long as they know the MAC address and start hijacking these connections. Now, the interesting thing is, they don't have to be able to physically disconnect and reconnect the port. There's no actual validation of the conditions. It doesn't say, oh, the port was disconnected, and then it was reconnected with a different one, and now that same MAC address is showing up on a different port, therefore I should start pushing packets to that new port. You just turn up and say, hi, I'm this MAC address. Even though the other one's physically connected, it will just start pushing the packets to you. There's no prerequisite checking at all. This is not resolved in a lot of SDN controllers today. So, yeah. So then this is the one that I think is the most interesting vulnerability. So by this point, the Onus project started to get a bit of traction. We're talking early 2015. And I thought, wait a minute, the same thing's going to happen here as happened to Open Daylight. So I got ahead of the game, established a security team, established a security response process, and then probably a couple of weeks after we set that up, one of the, it was actually a researcher in Taiwan who was doing a bunch of load testing and fuzzing, not for security purposes, but for QE purposes, of the platform, reported this vulnerability. So when I mentioned earlier that when an SDN, sorry, a OpenFlow switch encounters a packet that it doesn't know what to do with, it forwards that packet verbatim to the controller. And so what he found was that there was a vulnerability in some of the packet deserializers in Onus, and with these fuzzed packets that he'd created, he could get them to throw an exception. Now, one of the exceptions that he could get them to throw would just, this is just Java code, right? This is try catch, and there was no catch for that exception. So it would bubble up, bubble up, bubble up to this top-level exception handler that just said, that switch is broken, disconnected from the network, unknown error. So by sending a single packet through the data plane of a switch, you can cause that switch to become disconnected from the control of the SDN network and to be unable to communicate with other switches in the fabric. So it's a complete denial of service through a single packet of death. And I'll give you a, there we go, a live demo of that. So again, we're going to run the Onus SDN controller, and you'll notice the command is just the same. It's all Apache Carafe. In this case, we don't have to install anything extra. It's all there by default. So we'll just tail the log so that we can see what's going on here. That's all normal. Then what we're going to do is simulate a switch. I didn't want to have a physical white box switch, but you can simulate it using a tool called Mininet, and then you can attach it to the control of that Onus controller. So we'll run Mininet to do that. We'll just do a little bit of validation with ping all so everything's working. And now we can get an X term on one of the simulated switches. So on this, so we're now in the data plane of this simulated environment, and we're going to send a malicious packet. So there's a little Python script that just generates an invalid Ethernet frame, is what it is. And then you can see in the log, it's throwing buffer underflow exception, which is not handled. And then you can see it logs the fact that it's removing the switch disconnected from the network. So that's a rather interesting vulnerability. Sorry, this keeps going back to the start. But that was the last demo, so you won't have to see me page through it all again. Okay, so that's the offensive side of this. What about the defensive side? And I hope this doesn't clear the room out, because I know everybody wants to see the ownage. They want to see shells and things popped. But I actually think we have to talk more about defense, particularly for something like this. So what are the defensive technologies that we could adopt? One is called TapaGuard. And I mentioned earlier that some researchers identified that host spoofing, the packet in, you can say I'm that MAC address and just hijack traffic. They recognized that this affected a whole bunch of SDN controllers, and they also came up with a solution. That solution is called TapaGuard, and all it does is just verifies the conditions. Like I said earlier, there's no logic in there saying, in order for this to be a valid migration of a host to a second physical port, you need to have a correct sequence of events. You need to disconnect, that MAC address is not available anywhere for some period of time, then you reconnect, and that MAC address is still not anywhere else on the switch. That's a valid host migration. So it's just a little supervisor that sits on top of the SDN controller and verifies those conditions. Unfortunately, at the moment, it's tightly coupled to the floodlight controller, which is one that is really not used anymore. It was one of the first generation research projects. So I've suggested that this kind of technology be adopted by Open Daylight and Onus, because as I mentioned, they haven't even fixed this issue at all, but I'm not really getting any traction there. I think one of the issues with commercially backed open source development is that developers tend to have whatever the agenda of their employer is, and that's fair enough, so do I. But if it's nobody's particular corporate agenda to add this kind of thing, it just doesn't happen. Another one that I think is quite useful is security mode Onus. Actually, that's slightly out of date. Cardinal has now been released. So it's effectively just a mandatory access control implementation for Onus apps. It's very similar to SE Linux in theory, and it makes use of the Java Security Manager to do this. I don't know if anyone's ever tried to configure the Java Security Manager. It's a complete disaster. And there's many, many bypasses to it. All of those in-browser Java RCE flaws are generally all just bypasses to the Java Security Manager because that's what constrains applet execution in the browser. But this builds on top of that to give you a set of rules that you can apply to applications and say, so an application is kind of a module that provides some functionality within the SDN controller, and say there are things it can and cannot do. So you could say, for example, the OpenFlow module cannot read arbitrary files on the file system. So then or the netconf implementation cannot do that. So then if you had something like that netconf XXE vulnerability, you couldn't actually use it to do anything malicious. So I think that's quite cool. I mean, it can't hurt. The JSM has flaws, but it can only make things better rather than worse. But anyway, we all know that given human fallibility and the suckiness of Java, there will always be security vulnerabilities, no matter what kind of defensive technologies we introduce. So it's really critical that we have security response. And again, I hope this doesn't clear the room out, but this is something I'm kind of passionate about. I've run many open source security response teams, both for Red Hat and various upstream projects, and I've kind of learned a bit about how it works. And I think it's actually a case where open source has a real advantage over proprietary vendors. We'll get to that in a minute. But the basic problem with doing open source security response is that the whole open source ethos is that everything is open. Everything is completely public. Put it in a public bug, put it on a mailing list, and security requires the exact opposite. We need to constrain information, we need to keep it in a small group of trusted people. And so how do you handle this? How do you handle these two conflicting kind of ideological agendas of open source and security? And I think the answer is it's not that hard. You just need a dedicated security team with a documented process. And that process requires you to have a mechanism to report security issues through a private channel. Don't just file a bug. The team has to have a documented process for responding to the reports, a timeline for responding to the reports. They have to have the ability to build and ship a patch quickly for a critical issue. And then they have to ship advisories that clearly document the issue. It's not that hard, but a lot of these proprietary vendors can't do it. I needn't say much more about FireEye. Oracle is one who I love to pick on because I report a lot of security flaws in major Java components, not the JDK itself, but components in the Java ecosystem. And quite often there'll be an open source version, and then there'll also be a proprietary Oracle version. So the most recent one I reported was a remote code execution flaw in the JSTL, the Java Standard Template Library. So there's a version that's maintained by the Apache Software Foundation. They accepted my patch commit. They let me write the advisory myself. They credited me in the advisory, and they shipped the patch within a month of the report. Oracle, a bot responded to my report, ignored me for a year, and then finally in the most recent quarterly patch update, they shipped the patch. The description of the vulnerability was so vague that I don't actually know the CVE ID of the issue I reported, because there's 3 or 4 in that patch that could conceivably be that issue. So I think there's actually a real advantage here with open source because somebody like myself or anybody here can get involved and do it yourself rather than be beholden to the vendors. Anyway, I'll quit preaching. The other thing, though, where I think open source is at a bit of a disadvantage at the moment is what I'll call secure engineering or proactive security efforts, trying to reduce the likelihood that there's actually vulnerabilities in the code in the first place. So there's no well-established best practices. In the security response world, you can point to something like the Apache Software Foundation or the Apache Software Foundation. They're the only ones who really do it well. A guy up in Glasgow called Mark Cox, who used to be my boss, who wrote the initial OpenSSL implementation, makes sure that that works pretty well. But in the proactive security world, there's really nobody that you can look at as a shining example and say, that's how we should all do it for open source. The best one I could come up with is OpenStack. So OpenStack has 2 separate security teams. It's got the vulnerability management team, and it's got the OpenStack security group. So the vulnerability management team is, I want to say, 4 people who are all seasoned security professionals who work for big vendors that back OpenStack development, who know what they're doing. And the OpenStack security group is anybody can join, completely open membership. And the difference is that the VMT is the team that takes all the embargoed security reports, produces patches, ships advisories, coordinates disclosure. And the OSSG's job is just make security better in OpenStack, however you want to do that. A lot of it is kind of wasted time, but they've actually come up with some cool things. They came up with the cross-project security guidelines, which is actually good, and they've started to implement their own static analysis tool, written in Python for Python, that have been running over the OpenStack code base and actually finding real vulnerabilities. So that's cool. So what can we do to apply this to these Java-based SDN controllers? Well, here's my view. Secure development guidelines are great, but who adheres to them? I used to be a developer in a previous life, and if anybody told me to put curly braces on a new line or not on a new line, I'd do the exact opposite of what they said just to trigger that person's OCD. I didn't want to follow the guidelines. And so nobody follows these secure development guidelines. If you were going to follow them, you would have, you're a security-focused person anyway. Actually, this slide is from an older presentation, so you could ignore that bit about developer training, where I actually ran through a lot of these vulnerabilities with a different kind of audience. But you can do developer training, and that's okay, but it's extremely expensive. And it's very difficult to do in an open source environment. How do you take 500 collaborators spread around the world, all working from home, and actually put them through some kind of consistent training? It's very difficult. So my view is that what you want is automation. You want automated QE, CI, whatever you want to call it, automated tests that catch security issues and enforce the standards. And I think there's two key things you want to do there. One is catch known vulnerable dependencies. Particularly in the Java ecosystem or other languages where you've got a lot of libraries, you're pulling in all of these different libraries, all of which could have vulnerabilities in them. So you need some kind of fingerprinting to say, did you just introduce a vulnerability? And then you also have static analysis. The problem with static analysis is you get false positives. But there's a really good static analysis tool for Java called FindSecBugs. It's written by, I think, a French guy called Hexstream. And I always say it's the best static analysis tool I've ever seen because it only gives you 10 false positives for every real issue, which is so much better than all of the commercial static analysis tools that I've dealt with. So how have we applied this to these big SDN projects? So I'm going to focus on Open Daylight here for a minute because it's probably the most advanced. It's the one that I've spent the most time on. Security response, we've implemented pretty much what I just outlined. We've got a security reporting mechanism. It's security@opendaylight.org. Send it an email. There's a dedicated team from all the major vendors involved who respond to it in any time zone. And there's a security advisories page. So if you look at that netconf vulnerability we looked at earlier, there it is. There's a description, affected versions. We even link to the patch commits, and we give credit. This is so important. Anybody in the room who's a vendor, if you don't give credit, well, you're a jerk. It costs you nothing, and it's currency for security researchers, so please give credit. What about secure engineering, though? Proactive work. That's a bit harder. So there was a great analysis that was performed back before I even got involved in May 2014, where a lot of the people, the original contributors to Open Daylight, physically got together in a room somewhere in Silicon Valley, poured through the code, and found all of their failings from a security perspective, wrote them all up, and then never did anything with it ever again. So I picked up all that information and married it with everything that we've just discussed and said, you know what? We need somebody to work on this. I've got no money. I work for a startup. I can't convince you to hire people to do this, but you do have an intern program where they give you $5K USD for a student to work over the summer on anything we define. So this Northern Hemisphere summer, just ending now, I wrote up this project here to implement a secure engineering process for Open Daylight. And the main thing is to establish automated jobs that catch known vulnerable dependencies, automated jobs that run static analysis tools over the code, and then put all the findings in a queue. They scrub false positives that are identified from future scans. We document a threat model, and we improve the documentation so that the install guide tells you to change the admin default credentials. And that's all pretty much done now. Yeah, that's what the vision looks like to me, that it's an automated machine. So when you have a non-security issue or feature, the developer writes some code, they make a commit, it goes into the QECI, which is Gerrit and Jenkins for Open Daylight. There's static analysis tests, there's regression tests for specific vulnerabilities, and there's vulnerable dependency tests. If those pass, you get a build. If those fail, your build fails. But same deal, security researcher can actually report a security issue to the security response team. In the end, that patch commit will just be another developer commit, and it too is subject to the same tests. So even if you have a security patch which introduces a regression, it will be caught. And we have that automation in place today. So, stepping back from that deep dive into open daylight and open source security SDN, what are the next steps for SDN security as a whole? First of all, we need way more research into this whole data plane to control plane attack vector. The only actual instance of this that I've seen is that vulnerability in Onus. I'm not aware of any other specific vulnerabilities, but if you've heard of one, please yell out at the end. But there's no one really focusing on this stuff from an offensive perspective. Actually, when I submitted this talk, I had to convince these guys to stump up a lot of money to fly me all the way here. And I said, you know, look, I'm not the best speaker and I'm not the most technical, interesting guy in the world, but nobody's talking about this. So if you want some unique content, here it is. As far as I can tell, only myself and Gregory Pickett, the guy who's looking at the white box switches, are really focusing on this in any way. So if you want a gravy train, get on board the SDN security gravy train. Can we get a decent implementation that's not written in Java, please? Because Java, I could chew up another hour telling you everything that's wrong with Java from a security perspective. That issue with XXE that I pointed to was just the tip of the iceberg. Don't use Java. And could the big vendors please give a single fuck? That would be really, really good. I mean, when we established the security response team for Open Daylight, the Ciscos and so on of the world will say, oh yeah, we'll help, we're on board, but they're not leading it. They're not actually doing anything to improve the security of these SDN controllers. And if you remember back to those slides where I was saying that this technology is a threat to their core business, they're shipping commercial products built on top of this today, and they've got no security resources dedicated to it at all. Brocade, Cisco, they're all shipping commercial products built on top of Open Daylight, and the only person who's done any work on Open Daylight security is me and my intern, William Wu, in Australia. So yeah, that would be good. Okay, I'll wrap up there. I wanted to leave plenty of time for questions, so I think we have a member of staff with a mic, and just if you have any questions or comments or you want to berate me, throw up your hand.